This video is an introduction to a system of linear equations. We're going to focus specifically on systems that involve linear equations or lines. If we're going to talk about them, we need to know what is a linear system. A linear system is two or more linear equations with the same variables that we consider at the same time. For example, in business, we might want to consider the cost of producing our product and the revenue brought in when we sell our product. And when you look at the point of intersection between those two, we can begin to think about at what point do we begin to make a profit, or at what point do we begin to lose money. So sometimes in algebra or in real life, we have to consider more than one equation at a time. And when you do that, it's called a system. One of the key things about a system is the number of variables equals the number of linear equations in the system every time, all the time. The number of variables must equal the number of linear equations in the system. So if you look at the two examples that we have here on the screen, you'll notice that we have a system that involves x plus y equals 4 and x plus y equals negative 10. We consider those together. It's a system, and we have two variables and two equations. The other system we have here is x plus y equals 2 and 3x plus 4y equals 7. Again, considered together at the same time, that is a system. We have two variables, two equations. If you were to have three variables, you would need three equations. If you have four variables, you need four equations, and so forth. Now, they don't have to always be linear equations. They could be like a linear equation and a quadratic. We might have a quadratic and a circle. But again, regardless, number of variables should equal the number of equations that you have in the system. When we think about the solution set to a system, we know that the solution set to just a general good old everyday equation is whatever value or values make the statement true. Well, that also holds true for a system. The solution set to the system is all the ordered pairs. It'll take two numbers or three numbers if you have three variables, all the ordered pairs that are solutions to both equations. In other words, the ordered pair that you come up with, the value for x and the value to y, when you substitute them into the equation at the same time, they should give you a true statement. If they don't give you a true statement in both equations or in all the equations, then you haven't found a solution. Okay, so the solutions are the ordered pairs that make both the equations or all the equations true at the same time. When you think about a system and you're trying to think about solving it, there's basically three things that can happen. One option is that you would have exactly one solution. And typically, from a visual perspective, with exactly one solution, what you would have is you would have a set of lines or on a graph that intersect, and they intersect at a single point, and that point of intersection would be the solution to your data set, or to your system. So the point of intersection, and two lines only intersect at one point. The fancy algebra name for that is we call the system independent, because it has a single solution. If I have a system where I have no solution at all, visually what I would have is a graph where the lines appear to be parallel. They run side by side, they never cross, and they never intersect. And remember, parallel lines have the same slope. So that's also a clue that you might have no solution with the system is if you notice that both lines have the same slope, because that means they're parallel and they're never going to intersect or cross one another. A system that doesn't have a solution at all is called inconsistent. And then finally, the last option is that you have infinitely many solutions. And in this scenario, you would have a graph and you think there's only one line because you would have the graph of the first equation, and then when you graph the second equation, what you find is it's actually the same line and it's on top of the line. So that basically it's touching at every single point. We say the lines coincide. They're on top of one another and they touch basically at every point, which means we have an infinite number of solutions, and we call that system dependent. There are multiple methods for solving a system of equations. We can use a graphing technique. There's a method called substitution, and then a method that some texts refer to as addition, other texts refer to it as elimination. And we're going to take a look at each of these methods for solving a system, and look at some examples together in additional videos.